Right, welcome to Danny's Maths Hub. Now today I've just created a short lesson just going sort of through Venn diagrams and set notation. Now set notation can actually come without a Venn diagram, but I always think it's easier to see what they mean by using a Venn diagram. Now a Venn diagram is used to compare or group together two pieces of information, and it can even do 3 pieces, 4 pieces. You can do as many pieces as you like, it just tends to get a bit more confusing. The usual go-to point is 2 pieces of information, or sometimes even 3 in the GCSEs. Very rarely do we see more than 3 come up in the GCSEs. Now a Venn diagram could look like this, but it will always have a box around it. Now the reason we have this box is because every single piece of information we're given has to be within the Venn diagram, but not all bits of information can fit in these 2 groups, in these 2 sets. So if they don't fit in these 2 bits of information, these 2 sets, well they have to go on the outside, but they still need to be within our Venn diagram, which is in why we include the box. There's a couple of symbols we use when we look at talking about set notation and Venn diagrams. This is sort of the main one. This means every single member of these groups, these sets. Okay, so for example, it could be every single number is integers from 1 to 10. Okay, that could be every single number we're looking at in this Venn diagram, and it'll be shown using this. Where A could be our multiples of 2, and B could be our multiples of 3. And then we could put these numbers in. So if A is all our multiples of 2, well we know all our multiples of 2 are 2, 4, 6, 8, 10, because remember the only numbers we're interested in are integers from 1 to 10. So all the multiples of 2 would go in here. Okay, but remember B are all our multiples of 3. So 3, 6, 9. Now I think always the best place to start is looking at is there any the same, because if there's ones that appear in both sets, in both A and B, they have to go in the middle. Okay, 6 appears in both, so I'd put it so it's got to go in the middle. Now 2, 4, 8 and 10 does not appear in B, but it does appear in A, so 2, 4, 8, 10, you don't really need the commas actually. 2, 4, 8 and 10 is in set A, and then 3 and 9 are in set B, but they're not part of set A. And then everything else still has to be included. So if you think we haven't got the number 1 hasn't been around yet, 2, 3, 4, 5 hasn't been used, 7 hasn't been used. These 3 numbers are still part of everything we're looking at though. We're looking at all the integers from 1 to 10. So 1, 5 and 7 would go on the outside. Still part of our Venn diagram, but just not part of set A or part of set B. So that's how we use a Venn diagram, but these are the notations which may be the hardest thing to get our head around. And I'm going to rub these out because I'm going to be using these circles, this Venn diagram, to try and explain what each of these bits mean. So, first things first, if we want to know what's in A, well A is this whole circle here. Okay, if we wanted to know what was in A, we'd simply look at this whole circle. Everything that's in this circle is part of A, this whole circle. And I would often get probability questions like this to say, what is the probability of A? Well, if there's 10 things in A and there's 100 things altogether, well, it's 10%. Okay? So this could also be another way of writing what's the probability of picking something out of set A. So A just simply means this whole circle. B means everything in this circle. Okay, they're the 2 nice easy ones. A dash, you can see this is A with a dash in it, means not A. It means everything that's not in A. So that will include everything here, not this bit though, because that is part of A, and it also include everything on the outside. Okay, the only bit it wouldn't include is A itself, because we want everything that's not A. So A dash means not A. And B dash, well that means not B. So we want this bit, all the outside, but not B at all. We don't want B, okay, because we just want everything that's not in B, which would be everything in A that's not in the centre, and everything around the outside. And then we can start combining our sets, and then we use some very important notation. We use this to represent when we want to say and the union, okay, the U, if you like, to represent or. Now, language for the rest of these bits are very, very important, okay? And it may be at some point not sound like normal English, but it's understanding what it's saying. So the first one's quite easy. We want everything that's in A and B. So everything that appears in A and B, it has to be in both. It has to be in A and has to be in B. So it's this section here, isn't it? It's the only part of our Venn diagram where everything in here would be in A and in B. And then, so we've done this one. This one is A or B. It can be in A, or it can be in B, or it can be in both. A or B can be in A, or it can be in B. It can be in either or. Now, these ones, this top row, underlined in red, should be the standards. Okay, they should be relatively easy. Okay, this next row gets a little bit more confusing, and then this bottom row is maybe where it gets the most confusing. So let's look at what this next one says. This says A and not B. So we want everything, it has to be in A and not. So it's and, so it has to meet both of this criteria. It has to be in A and not B. So actually, it's only this section. We can't count this section because it has to be not in B. So we can't count this because this is in B. But it also has to be in A, so it can't be on the outside. So this is A and not in B. A and not B is just this section here. And then if we look at the reverse, not A and B, not A, but it has to be in B. It has to not be in A, but it has to be in B. So that's that section there. Then, if we have A or not in B, so it just has to match one of those. Okay, so A or not B, which means we have this bit, so we know this is A. Okay, but it's or, so it only has to meet one of them. So we can still include this bit, or not B, and this is also not B, isn't it? So A or not B is everything in A and everything on the outside. The only bit we don't include is when it's just B. So it has to be one of the two type criteria, in A or not in B. And then not A or B would be everything on the outside again, everything in the middle, and everything in B. Just not just A. So A or not B, and not A or B would look like this. Obviously this bit would be over there for the first one. So there when they get a little bit harder and you have to think a bit more. Now these two are when the language gets really, I think, quite confusing. We want everything that's not A or not B, which actually, when you say it out loud a couple of times, you can start hearing it, it's the same as saying we want everything that's not A and B. Okay, so A and B not with the dash. So really that's saying we want everything in A and B, or on the outside, just not what's in the middle. Okay, not A, so this is all not A, because we covered that in earlier, or not B, we covered that all in earlier, which is the same as saying A and B not, so not in A and B. So this would be the only section not coloured in. Okay, A, not A, or not B. And then last but not least is not A and not B. So it has to meet both criteria, which means we cannot include this bit. Which is actually the same as saying A or B not. So not in A or B. So there's still a couple of ways you could write the same things over again. Now that was a very quick whistle-stop tour of Venn diagrams and the set notation. Obviously there's so much more to it, but because I was specifically asked to do a quick lesson on it, that's what I did. Obviously I'm still teaching throughout the day and we're still doing a lot of work on the Maths Hub in the evening, so I tried to squeeze this in. I do hope this covered enough information for you, but obviously if not, please do drop me a message and I'll try and help out where I can. Have a great day everyone. I've said this already in my live lesson earlier, but I do hope you have a great evening and I'll see you tomorrow.